Okay, let's manipulate. Well, what I'm going to do first of all is I'm going to take this cosecant up top and turn that into its reciprocal identity. 1 over sine times this cosine of x. So cosecant was 1 over sine of x times this cosine of x right here over cosecant. I'm going to go ahead and call that 1 over sine of x minus this sine of x over here. Now, you definitely cannot divide these two out because it is minus sign. Anytime you have a plus or minus sign there, it's a no can do. It has to be in multiplied form. Like if this was multiplication here, then you could go ahead and divide those two out. All right, so I got to work with what I have. Now, can I say that's cosine of x over sine of x here at the top? I sure can. How about at the bottom? That's not multiplication. But I could think of this as 1 over sine of x that comes down right here minus, and this is really the sine of x over an understood 1, right? All right. I want to get everything to one term because this is just one term, okay? So I want to subtract these two right here. To be able to subtract those, I need a common denominator here and here. Well, couldn't I just multiply this one by sine of x over sine of x? And that'll give me the same denominator here and here. All right, so we're going to have cosine of x over the sine of x up top over, this is 1 over sine of x here, minus, this is sine of x squared over 1 times the sine is the sine, right? All right, so the numerator comes down, cosine of x over sine of x. Now the denominator, I'm just going to write the sine of x down one time, and I'm going to subtract the numerators. 1 minus sine of x squared. Oh, what do we think of whenever we think of 1 with a sine squared? We think of a Pythagorean identity, right? So what's my Pythagorean identity with 1 and sine squared in it? I cannot find my other color marker. There it is. I think of this Pythagorean identity. Sine squared plus cosine squared is equal to 1. Now, I'm just not writing the x there, but I know to put it in a little bit. What do I need? I need 1 minus sine squared. So what if I subtract the sine squared? I have cosine squared is equal to 1 minus sine squared, right? So 1 minus sine squared could be replaced with cosine squared. So that's the cosine of x over sine of x comes down right here over, we said we're going to replace that with what? Cosine squared. Be sure you put your x in it. Over sine x. All right. Well, we're still trying to make this look like that, right? So let's come over here and let's say, okay, I have cosine of x over sine of x here, but let's multiply by the reciprocal. Let's say that's times sine of x over cosine of x squared. Well, what happens to these sines of x's? They divide out, and you're left with cosine of x over cosine of x squared. So that gives you 1 over what? Cosine of x? Well, what's 1 over cosine of x? Also called the what? Secant of x. Did I get where I was supposed to? I sure did. All right, let's go back to D as in dog. D as in dog. D as in dog. All right, before we do D, here's why I wanted to go back to D, okay? Let's rehearse some of these properties, or let's look back at some of these properties we had in a previous math class for logarithms, okay? Didn't we have a property that said if I have the log base b of x plus the log base b of y, I could do a rewrite in that case. I could say that that is equal to the log base b of this argument times that argument, x times y, right? We also had a property that said this. What if I have the log base b of x to the r, where r is some number, okay? Then what I could do is I could pull the r to the outside and say that's r times the log base b of x, like that. All right, we also had this property. So what if I have the log base b of x minus the log base b of y? So if I have two logs being subtracted with the same base, I could rewrite that as a log with the same base of this argument over that one, x over y, like that. All right, we're going to use that here. We have natural log of the absolute value of cotangent of t minus natural log of the absolute value of tangent of t is equal to 2 times the natural log, 2 times the natural log of absolute value of cotangent of t. Absolute value of cotangent of t. Let's see. Let's verify this. Left looks a little more complicated, so I'm going to start with this left side. Natural log, the absolute value of cotangent of t minus natural log of the absolute value of tangent of t. And I'm going to work with that. Well, let's see. These are both log base e, right? For natural log, it's an understood base e. And they're being subtracted. That's this property right here. If they're being subtracted, what do? I write it as one log of argument over argument. So I'm going to rewrite this as one natural log of this argument, absolute value of cotangent of t, over this argument, absolute value of tangent of t. Now what I'm going to do is I'm going to rewrite this as natural log of, I can write this if it's a fraction like this as one large absolute value of cotangent of t over tangent of t, like that, all in one absolute value. Let's mess around with this inside here. Could I say that this is the natural log of the absolute value of cotangent of t times the reciprocal, or 1 over tangent of t, like that? Because if I multiply this, I'll get an equivalent thing here, right? So I could say that's the natural log of the absolute value of cotangent of t times, well, what's my identity for 1 over tangent? That's cotangent, right? Well, let's keep going over here. So if I come over here, that's going to be equal to the natural log of the absolute value of cotangent of t squared, right? Just bring this down. We have log base b of x to the r is equal to r times log base b of x. All right. This is the same thing as writing the natural log of the absolute value of cotangent of t squared, like that, okay? Or I could say, okay, this is the natural log of cotangent of t in absolute values, like that. I'll tell you what, let's just do this. Let's just use this property here, okay? It says, what can I do with that R value? That's my exponent. I can pull it to the front and say that's 2 times the natural log of the absolute value of cotangent of t. Is that where I want it to end up? Sure is here. Be patient with yourself with this stuff. This stuff is tough. It takes a while. I want to make a special note here. Whenever you're doing this stuff, verifying identities, sometimes you work with stuff and you don't get anywhere. Instead of erasing all that stuff, put a line through it, okay? Because it'll remind you later, don't go try that same thing again, okay? You tried it and it didn't work. So try it again. Good luck with the homework, folks.